All right, so what I'm looking at right now is I'm looking at question number 5 on 4.2, and this is an expected value question. This is actually a pretty standard expected value question. And what I wanted to do is with this, I wanted to go over the process of doing expected value. So we've got this question. Robert bought a $5 lottery ticket such that 1 in 100 would win $10, 1 in 1,000 would win $100, and 1 in 50 million would win $1 million. What is the expected value of a lottery ticket in dollars? So the first thing that I do whenever I'm doing expected value or working at expected value is I'm actually going to generate a discrete distribution here. And the first thing that I want to do to generate that discrete distribution is I'm going to write down all the possible outcomes that could occur. Okay, so the first outcome that could occur is win $10. Okay. The second outcome that could occur is win $100. $100. The third outcome that could happen is win $1 million. Okay. And then finally, the fourth outcome, actually, and the one that's not generated here, but that you have to remember, is you could not win nothing. So that's the fourth outcome. And you have to remember that that's actually a possibility. Anytime you're doing any of these things, you got to sit down and go, okay, what are the different possibilities that I could have? Okay. Then next, you've got to go, okay, well, are there any that aren't actually listed but are kind of inferred? And that last one is win nothing. Now, what I'm going to do with that is I'm going to generate a discrete probability distribution. Okay. And so this is going to kind of come from earlier on. We had been working on these before. Okay. So I go in and insert a table. 2, 3, 4 options, plus I'm going to use a total option, and then I have one for the columns. And then I'll have, so there's the 1, 2, 3, 4. Yep, that's what I'm going to do. Okay. And the reason why I chose that many is, one, I'm going to have the outcome. That's going to be my first choice. My second choice is going to be the probability that the outcome occurs. And that's P of x equal to x. That's oftentimes how we write it, at least mathematically. And then we have x equal to x. That is the value of the outcome. Then we're going to have x times P of x equal to x. And then that's going to be, it's just a calculation that we're going to use. And so it turns out we actually only need the four outcomes, the 4 things. So the first one here is the win $10. The second one's the win $100. The third one's the win $1 million. The fourth one is win nothing. And this final one here is going to be is the total. All right. So now I have all of my occurrences and my outcomes. It's always about setup. We always want to think, okay, set this up first. What are the things? How are we going to set it up? Okay. And then it's basically utilizing the information in order to fill out this table. The next part that we're going to need here is the probability of each one of these events occurring. So for a $10 ticket, it's going to be 1 in 100 will win $10. Okay. So that's it's 1 out of 100, which equals 0.01. Okay, we're going to use the decimals in a little bit. Then we're going to have 1 in 1,000 would win $100. So that's 1 out of 1,000, which equals 0.001. Then my next one is going to be 1 in 50 million would win $1 million. So that's going to be a little bit tougher. It's 1 out of 50. 3, 4, 5, 6. Okay. And so what we'll do is we'll use, okay, and so that ends up giving me this value here that I have of 0.0002. See if I can actually. That's 1, 2, 3, 4, 5, 6, 7 zeros. 1, 2, 3, 4, 5, 6, 7 twos. Okay, so it's got a very low likelihood of occurring. Now, we also need to figure out the probability that we win nothing. So the probability that we win nothing is actually going to be the complement. If you remember from probability, it's the complement of the other three occurring. So it's going to be 1 minus, okay, 0.01 plus 0.001 plus 0.0000002. Okay, so there that is. All right, that's the idea that if you don't win something, you're just going to win nothing, and so hence everything else is a winning of nothing. Okay, so that ends up giving me 0.988. Okay, let me make that a little bit larger. 0.9889998. Okay. Now notice I utilized all the decimal points that I possibly had. I actually gave an exact answer here. The reason why is that expected value is somewhat sensitive to rounding, and so I don't do all my rounding until the very end. So I'm going to actually take, as I'm doing my work here, I'm going to do it all with non-rounded numbers. Okay. All right. So now next, I need to fill out this third column right here, the x value of the outcome. Right? Well, we're given what those values are. And actually, it's not that hard. The value of the outcome for winning $10 is $10. Okay? However, here's the thing, and this is where it's tricky. It's you win $10, but you spent 5 to get it. So it's actually going to be 10 minus 5, which equals 5. Okay? You have to account for the fact that you are, in fact, spending something. Okay, here. Now, there are alternative ways that you may see online in which they take 10, 10, 10, right? Okay. And what they will then do is take the probability of all three of these and subtract it from the total. I'm not doing that right now. I'm doing something slightly different, but that's also valid. Okay. For this method, though, you have to remember to subtract out the 5. Okay. Same thing here. When I win at 100, it's actually 100 minus the $5 for the ticket. Okay. So that's 95. And then I have $1 million, and I still have to deal with 1 million. 1, 2, 3, 4, 5, 6. So there is minus 5, right? Which is equal to 999,995. Okay. And then winning nothing, it's 0 minus 5. Okay. 0 minus 5, and there you go. Okay. All right. So now what I have is I have a discrete distribution, a discrete probability distribution. And so what I can use, because I'm looking for an expected value, is I can use the mean formula that I use for discrete distributions. So that's going to be 0.01, right? We're going to multiply x times p of x, right? Or p of x equals x times x. So that's 0.01 times 5, okay, which is equal to 0.05. Okay. Next up, I have 0.001, right? My p of x equals x times 95, which equals 0.095. Okay. Then what I'll have is I'll now have this much smaller number. So I'm going to pause for a second and go do the calculation. But that's basically going to be 0.0234567 twos times 999,995. Okay. What I get when I multiply that is basically a little over almost 2 cents. Okay, but again, remember, I'm not going to round until the end. So I end up with 0.019999. Okay. And then this final one here is going to be that value, that 0.988, 0.9889999 times negative 5. What's this? Okay. All right, we're just going to equal negative that. Okay. Basically, $4.94, about $4.94. Okay, negative. Then all we need to do to find our expected value now is to add them all together. Okay, so do that. So just like with the expected value, I'm just going to sum up all of these here, and when I do, what I end up with is I get a negative $4.78. Okay, so 0.05 plus 0.095 plus 0.01999999 plus negative 4.944999999 turns out is negative $4.78. Okay, so that's our expected value. That in fact is the answer to our question. What is the expected value of the lottery ticket in dollars? Well, it's negative $4.78. Okay, and does Robert expect to earn a profit if he buys 100 tickets? Well, the answer is no, he doesn't, because he has negative expected value. Okay, so let's write that down. That way we can be real clear about this. Negative expected value implies that we lose money or value every time we do an event. Okay, so like in this case, every time I purchase a lottery ticket, I'm losing money. How much am I losing per lottery ticket? I'm losing $4.78 per lottery ticket. That's what that expected value says. Okay, I am losing, in this case, $4.78 per ticket. Okay, so I would lose $4.78 times 100 tickets, which is equal to $478 on the 100 tickets. Okay, if the expected value is positive, right, then I'm expecting to gain money. Okay, negative expected value is to say, okay, I'm going to lose money. Positive expected value says I'm going to gain money. Okay, and so that's kind of like our decision making. If it's positive, play it. If it's negative, don't. That's the idea. Okay. Now, in terms of setting up your table, once again, let's just review real quick. First, go through and utilizing the information that you've gotten for the problem or the scenario, construct all the different things that could occur. Okay. In this case, we've got these 4 different occurrences. Place those into a table as your outcomes. Then calculate the probability of each one occurring. That's your second column in the table. Your third column should be the value of each one of the outcomes. All right. And so like in this case, and don't forget, if you're utilizing the process that I am, where you're actually including win nothing as an option, then you need to subtract the cost or the value of actually playing or doing an event. Okay, in this case, it's the $5 ticket. Finally, what we're going to do is calculate the expected value by multiplying the probability times the value of the outcome, okay, for each one of them, and then adding them all together. That gives me my expected value, and that's how you find expected value. I hope this was helpful.